one of the several forecast products and research efforts that has been underway and ongoing and actually completed in this case at CW3E. This will be a focus on our subseasonal atmospheric river activity outlooks. So this is, like I said, one of a suite of products that we update and maintain regularly at the center. This is an effort that is sponsored primarily by the California Department of Water Resources and was developed in partnership with the NASA Jet Propulsion Laboratory. And I've also listed a number of collaborating institutions at the bottom here that have been vital in, helping us design the research that went into this and, ultimately making this something that can be used as a product by the community. So just a quick background here and sort of as promised, an overview of what we mean by S2S and subseasonal to seasonal. This is an adaptation of a figure that was published in EOS earlier this year with Dr. Marty Ralph, who's the director of CW3, Dr. Dwayne Walliser, who's the chief scientist in the Earth Science Directorate at JPL, and also Janine Jones and Mike Anderson from DWR. So this was really a collaborative research and stakeholder effort that described the motivation for improving subseasonal to seasonal prediction in the practical world and why we need to focus on it in the research community. So if you look at the bottom axis here, we created a forecast lead time here that goes from daily all the way out to decadal and century lead times. So going from days to centuries, we have this dynamic range of physical processes and also decision support needs in the water management community that vary as you change the lead time that you're interested in. And I just wanted to highlight, the motivation is well-founded, I think, among this group for why we care about longer range prediction. But I just wanted to highlight that in this article, there are a number of decision points and decision support needs from water managers that are articulated and conveyed to the scientific community. And it's kind of meant to raise awareness to the research world why this topic is important for Western US water managers. And for subseasonal to seasonal, along this continuum, we really mean 2 weeks or so as the start of lead times for subseasonal, out to seasonal, which is 3 to 6 months of lead time towards the longer range. So that's the sweet spot that we're going to focus on, that our team focuses on at CW3, and the early part of that is really the focus of this talk. So this effort, as I mentioned, is a partnership for CW3 with the NASA Jet Propulsion Laboratory, and also has significant involvement from our stakeholders at DWR. And we have been participating in the development of these subseasonal AR activity outlooks with the World Meteorological Organization. So that's an umbrella under which the World Climate Research Program and World Weather Research Program sit. And they have started in the last few years a real-time pilot initiative, which basically has a group of teams, 16 total, that use real-time information from the S2s project database, which is run by the WMO. And basically the idea here is for these different groups to use data in real time to help answer specific needs for an end user. So in this case, our group is the only group of the 16 that's focusing on a Western water related application. And the idea here is not only to make use of the data that the S2s Real-Time Pilot Initiative is providing, but also to raise the visibility of water manager needs in the West for this longer lead forecast info. And you'll soon be able to read about all of the projects, including ours focused on Western US water, in a BAMS article that's currently in revision. And it's a nice way for the needs of water managers here to really be expressed and elevated on an international stage. So within CW3 and in partnership with JPL on this topic, I wanted to give an overview to this group of how we go from a research idea to a forecast tool that can be used by the broader community, including stakeholders. And we've taken a lot of time within our group to develop this pipeline, and it will serve as a template for how the subseasonal AR activity outlooks that I'll show you were developed. That was a kind of a test parcel that went through this entire process. So the projects that our team focuses on in our S2S group are initiated in several different ways. First of all, topics that are identified are based on advances in relevant sciences. So, topics that are of interest broadly in the research community, but also just as importantly, they're based on stakeholder needs. And our team has included direct input at the beginning of each research project from our stakeholders at DWR in particular on the methodologies that we use, how the experimental products are displayed ultimately on our website, things like target predict band, lead times of interest. It's all kind of a dynamic discussion and collaboration with stakeholders from the onset. And what we then do after the research projects are identified and sort of hatched in this way, we have a vehicle within CW3 that we call our S2s Advisory Panel. It's made up of a group of experts, both at Scripps and at JPL. And the idea is to provide feedback on these projects as they go through their maturation. And part of that is to ensure responsiveness to stakeholder needs. So this group of experts is really having an eye on whether or not the research projects that are ongoing before they get, into a forecast tool format are being responsive to those needs. And we have a focal component of this is that the skill assessment of any prediction system we use, whether it's a dynamical ensemble system like NCEP or ECMWF or a statistical model, gets evaluated in a peer-reviewed literature framework before we post anything to our website. So the AR activity outlooks that I'll show you are based on, having gone through this entire process, including a number of peer-reviewed hindcast skill assessments that basically show how good these models are at making predictions of past forecasts. So the vehicle described in the previous slide ultimately leads to forecast products being posted on our public website. So you can go to the CW3 website, go to the forecast tab and look at the subseasonal to seasonal forecast page. And this product that I'll focus on in the last few slides here is the first such product on the page. So these are basically the week by week examples of what the AR activity outlooks look like. If I could go back in my memory and think of the first version of these when they were developed, you can imagine they were much different. We've revised these and iterated on these extensively, both with the advisory panel group and with Mike Anderson, who's on the line from DWR, for example. So what we're showing here is a forecast. I wanted to use the latest outlook to show you all that this is a thing that's regularly updated, and it's currently being examined by our team and by various end users. So this is an outlook from the NCEP forecast system, initialized on the 11th of October. And each of the panels here is showing the probability of an atmospheric river occurring at a grid cell by grid cell basis at 0Z of that day. So it's a snapshot out from 1 day lead all the way to 7 day lead. And the shadings represent the fraction of ensemble members in the forecast system that agree that an AR will occur. And the ARs in this case are detected from an AR detection algorithm that's based on IVT data, geometric constraints, and other criteria. But it's basically saying, will there be an AR or not? So in this particular example from this most recent forecast, if you focus on California, you see really a deficit of atmospheric river activity predicted for each day. We can now extend further out. That was for week 1. Now we extend further out into week 2, which is really getting into the early part of the subseasonal prediction range that I outlined earlier. So you can see from this particular forecast model for this week, so week 2 will start at 0Z on the 19th, so about 4 days from now. And you can see much higher probabilities in this example for atmospheric river activity to impact, say, Northern California. And you can even see elevated probabilities out to the end of week 2 over the British Columbia region, Pacific Northwest region, and extending into Northern California. And this is, again, using daily probabilities of atmospheric rivers occurring. It's treating each day as an individual day upon which AR probabilities are evaluated. So the last slide here is showing really a twist and a wrinkle into this methodology. And this is really highlighting a common technique and a common philosophical shift that we get as we go out into longer and longer leads. So now we're looking at the same forecast. This is October 11th in the NCEP model, but instead of looking at daily probabilities of AR occurrence, like we did for week 1 and week 2, we're now shifting to a weekly aggregate. So the top panel is showing the number of days in an entire week-long period, in this case, week 3 lead time, verifying October 26th to November 1st, the aggregate count of AR days that are predicted during that week. So that's what the top panel is showing. And you're getting into the saturated greens here, which means, you know, a day and a half up to probably 2 days in some cases of the 7 days are predicted to have an atmospheric river occurring. The middle plot is what typically happens in the hindcast climatology. So that's the average for this week over a number of years in the historical record. The bottom panel is just the top panel minus the middle, and it's showing you an anomaly forecast relative to average conditions in the middle of what we can expect for this week, for week 3 in this forecast. So the blues that you see here over the Pacific Northwest and much of California are saying that we have an above average chance for AR weekly activity for week 3 for this forecast. And you can kind of see that just qualitatively comparing the top panel and the middle panel. The top one is showing, you know, much higher elevated aggregate numbers of predicted AR activity. So this is an example of how we shift our forecast lead time, you know, perspective as we get further and further into the future. We get away from making daily forecasts of different predictants and instead, you know, relax our temporal criteria for what we're trying to predict in an effort to increase skill. So in summary, to wrap up here, I know this group is very well versed in the idea here that we have very high interannual variability of wintertime precip in the Western US, and especially over California. And there are many lead time dependent needs that water managers have for more skillful, longer range predictions. So this combination of motivations, along with increasing demand from other end users, has led to this really heightened international investment in subseasonal to seasonal research that was kind of articulated in showing the WMO real-time pilot initiative. We see it on a state level and also on a federal and international level. And the focus here is on better understanding of physical mechanisms. We didn't get into that so much in this talk, but looking at what physical mechanisms in the climate system relate to predictability, things like the Madden-Julian oscillation, the El Nino Southern oscillation, et cetera. And we have this end goal of creating actual forecast products that can help meet end user needs. And just to call out again, California Department of Water Resources has been an amazing sponsor in this research and operations partnership between CW3E and JPL for the atmospheric river activity products. We have other products that are undergoing testing and will eventually, you know, if all goes well, be released on our website. And again, a key here is that all of this, including the methodologies of the research and the display of the products, have been designed in tandem with our stakeholders to help best meet their needs. So I'll wrap up there and happy to take any questions, or we can maybe save them for the end if that's preferable.